Dividing monomial, quite a few days with different activities talking about multiplying monomial and dividing monomial. Do that. So right at the top of your notes, quotient, guys, what does that vocab word quotient mean? It means divide. So when you're dividing monomials, all you have to do right here is subtract the exponents. So before we had a situation where we'd add the exponents and a situation where we would times. Today if you're dividing, it's only one rule. You subtract the exponents every single time. So there's those little with variables in there. There's right underneath it, there's some room on your notes. Let's just make up our own example. If you have x to the 10th over x squared, first you gotta check yourself, is this really dividing? Makes sense, right? So we're dividing monomials. All you have to do in this situation to show your work is write x to the, take those exponents, subtract them, x to the 10 minus 2. What is 10 minus 2? You're done. Again, the rule today is subtract those exponents. You get that example down, not too bad. Now there is going to be a situation, let's do one more example, where what if you have, we have e to the 6th over e to the 12th. Okay, you always do the numerator minus the denominator. So like Terrence said, you're going to get a negative. So you would write it down. This would be your work. You do e to the 6 minus 12. Well, what is 6 minus 12? It's negative 6. Because there's a rule with negative exponents. Negative exponents always have to go in the denominator. So we've got to create a fraction for ourselves. So if this goes in the denominator, it gets to become a positive. So put this in the bottom. So that would be e to the positive 6. Well, if that's in the bottom, any guesses what would go in the numerator in this situation? Just put 1. 1 over e to the 6. Let's do another negative example. Seems like you ate up the positive examples. Let me erase this board. Okay, one variable in it. Has g squared h to the 8th, because will you get this one down, over, let's just do g and h to the 11th. Okay, first off, that g that's in the denominator, what's the exponent on that one? This one right here at the bottom, what's this exponent? Okay, make sure you add in those invisible exponents, so that's the 1. So in this situation, we'll do g to the 2 minus 1 and h to the 8 minus 11. Okay with that, we just do top minus bottom, top minus bottom. So g would just be to the first power, right? That's g to the first, h to the, what's 8 minus 11? Negative 3. Okay, so there's one of those that goes in the numerator because it's positive, and one that goes in the denominator because it's negative. Do you know which is which? Where does g go, top or bottom? C's in the top, and do we really need that 1? No, so let's put g in the top. And then do you agree that h gets pushed to the bottom? Now be careful, do we have to put negative 3 down here? No, since we kicked it to the bottom, we can now switch it to a positive 3. Do you want one more example of this? Chelsea, question.
So when you're minusing them, you need to have it in the same order as like top to bottom?
Yes. Chelsea's question was, when you minus them, do you have to have them in the same order, top minus bottom? Yes, always. Always do top minus bottom. Taryn, question? Oh, you want to get into the examples? Okay, let's get into the examples. All right, so here we go. We've got this very first one, a to the 4th, b to the 7th, over a b squared. First, check yourself, guys. What's the exponent on this denominator a? 1. Put it in there. Don't forget those, because you got to remember to subtract it out of it. So this one, like Chelsea reminded us, you got to do top minus bottom. So a to the 4 minus 1, b to the 7 minus 2. Okay, what is 4 minus 1? Alright, so that'd be a to the 3, b to the what? Okay, do we have to put any, like, in the denominator? How do you feel about this one? Are they both positive answers? So just circle it. You don't have to do any moving around because they both come out positive. Okay, let's keep going. Alright, guys, beat me to these ones. You can handle these ones. They're actually really, really nice. So this first one, we've got 5 to the take your exponents, subtract them, 5 minus 2. So that would just be 5 to the third. Let's put both answers. Let's put that one, and let's put what that number actually is. So 5 to the third means 5 times 5 times 5. Bust out those calculators right here. Type it in, 5 times 5 times 5. Let's get the exponent and the actual value of this answer. Okay, let's put both. 5 to the third, which is 125. Okay. So next one we've got m to the 6 minus 4. Because what's the final answer on this one? Nice, right? These aren't too bad. Okay, last one, we've got one where we have two variables in one situation. Perfect, Gabe. So we do p to the 5 minus 2, n to the, don't forget to put in the 1 there, n to the 4 minus 1. So Gabe said that's going to be p to the third, n to the third. Okay, do we have to do any moving around on that one? No, they both came out positive, so just circle it, you're done. Okay, I kind of want to manipulate your notes to make some negative ones. Let's go to the now. Okay, let's add in on number 4. Let's pretend like it really started with a to the 6th power on the bottom. So add in the exponent. So in this situation, we would do a to the 2 minus 6. Problem, what happens when you do 2 minus 6? All right, negative 4. So since it's a negative, where does that go? Goes in the denominator. So final answer on this one. You want a to the 4th. Taryn, remind us what goes here? Yeah, put a 1 right there. Good job, we remember. Okay, so number 5 has something we haven't talked about yet. So we'd have x to the 5 minus 5 over y to the 3 minus 2. And what happens to the x? Gone, because anything to 0 power is 1. So our x's are gone. They eliminated themselves. So this one would just be y to the 1. But do we really need that 1? No. So like Eric pointed out, just y. We just added it. Okay, so number 6 also has something we haven't talked about before. Now we've got numbers in here. All you have to do when there's a number in there is simplify it. So can you think of a number that goes into -2 and 14? Negative 1 goes into them both, but we want to make them smaller. Oh, good job. -2 goes into both of them. We could just think of it as 2. So guys, what's 2 divided by 2? 2 divided by 2 is 1, so let's change that to a 1. And then what's 14 divided by 2? So let's change that to a 7. So all you have to do with the numbers is reduce them, and then they just tag along. Alright, and then your exponents, we would just have y to the 7 minus 5, right? What is 7 minus 5? 2, so does that go on the top or the bottom? Okay, in the top, we still have that -1. Do we really need to write the 1 though? No, let's put in the negative. And then in the bottom, we would have just the 7. Oh, the numbers. Chelsea's question was, doesn't have to be in the bottom because it's negative. Now, Chelsea, this is saying negative y to the second. It's not saying y to the negative second. It's only if the exponent is negative does it go on the bottom. That's a great question. So again, I just took this -1, I left it up top. We don't really need the 1. We already figured out that 7 minus 5 is 2, so that stays in the top. And then 7 is the only thing left in the bottom. Let's do another one. Okay, so our last 3. Same thing with number 7. We've got to reduce that first. Does anybody know the biggest number that will go into 12 and 36? 6 does go into them, but there's a bigger one. Sam, do you know? 12 goes into them both. So what's 12 divided by 12? 1. Alright, so this is a 1. When we divide by 12, what's 36 divided by 12? Good job, guys. So if we want to rewrite it, it'd be n to the 5th over 3 to the n. But we can subtract those exponents. What's the exponent on this bottom end, guys? 1. So we have n to the 5th minus 1, which is just going to be n to the 4th, right? So it's n to the 4th in the top or the bottom? Top. Do we have anything in the bottom? The 3 still on the bottom. So it'll be n to the fourth over 3. Good job. Okay, let's go to number 8. Number 8, guys, what goes into 9 and 3? 3. So what's 9 divided by 3? So this would be a 3. What's 3 divided by 3? So that's a 1. So now we have 3d to the 7 over 1d to the 6. We don't need to write that one. Alright, so that would be d to the 7 minus 6, which is just d, right? But does that d go in the top or the bottom? Top. What else was in the top already? So we've got 3 and a d. Do we have anything left in the bottom? Oh, you're done. Okay, our last one, number 9. Okay, what goes into 21 and 7? 7? Alright, so what's 21 divided by 7? So this, let's keep it as a negative 3. 7 divided by 7 is just 1. Alright, so here we go. We've got negative 3, w to the 5th, u to the 2nd, over w to the 4th, u to the 5th. And then here we go. So that would be w to the 5 minus 4, u to the 2 minus 5, right? So w to the 1 is what Gabe said. U to the what, guys? Negative 3. Crap, we're going to have to deal with that. So let's move this out of the way so we have a room. And don't forget, we had a negative 3, right? In the top. Okay, where does the w go? Top or bottom? So we've got negative 3w in the top. And where does that u go? Top or bottom? Bottom, because it's a negative. But check yourself, guys. Do we write u to the negative 3 in the bottom? Now just put u3. Okay, that's it. How are you feeling about this?